So, first thing I've got on here is I have a really, really blurry circle with all of our degree and radian measurements on it because I am not in the business of making you rethink about that in your head 1,000 times. So,
why is it so blurry?
Because I copied and pasted it. It wasn't blurry when I copied and pasted it.
You didn't do the intro. You didn't make an intro. Hi, welcome back to the Trig class. Today, third hour. Nothing.
Okay, so first thing that you need to know in the first 4 questions on the review, the first 2 questions on your test, quiz, whatever we're calling it, is to convert from degrees to radians and radians to degrees. In order to convert from degrees to radians, you need to multiply by
27.
pi over 180 degrees. In order to convert from radians to degrees, you need to multiply by 180 degrees over pi. Look, it's just the opposite. If you are converting to radians, leave it in terms of pi. I even wrote that. Express your answer as a multiple of pi. Okay? So, 2 of each of those on the review. There's 1 of each of those on your quiz. Okay? Next thing that we need to know. Coterminal. Co means same. Terminal means ending. My patience for Kyler and Lucas is coterminal. It is ending at the same time. In order to find a coterminal angle, you want to add or subtract either 360 degrees if you're in degrees or 2 pi if you're in radians. If you want to be able to afford a good toupee when you lose your hair, you need to graduate from high school and do your trigonometry. Okay, there is 3 of those on your review. There is 1 radians and 1 degrees on your quiz. Yes?
When am I going to use this in the real world?
Right now. Okay, this is the real world. Welcome to reality. Reciprocal functions. Reciprocal functions are the functions that they are the, like, take the fraction, flip it. So sine is the reciprocal of cosecant.
That sounds like the same name that they call the little flame.
Cosine is the reciprocal of secant. And tangent is the reciprocal of cotangent.
Yeah, I know this.
Pretty confident for a guy who doesn't think knowing any of this is worth anything.
Oh, she basically said you're a dumb idiot. Wow, Mrs. Hell.
Did I?
A dumb, stupid idiot in front of the entire class.
Did I say that recording? Did I? Did I though? Okay.
Yeah.
Cofunctions are the ones that have the word co in front of them. So sine is a cofunction with cosine. Tangent is a cofunction with cotangent. And secant is a cofunction with cosecant. Okay, so you got to know which ones were reciprocals of and which ones were cofunctions of. On your review, there's 2 cofunctions. On your quiz, I think there's, did I put 1 or 2?
How many questions were on the test, Mrs. Hell?
I put 1. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
That's a lot of questions.
It is. So many questions. All right. Then let's go ahead and fill out this little table of our 6 trig functions.
Did you make this?
Yeah, I did. Yeah, I know. I tried to use fun little shapes, but then the little shapes weren't big enough. I tried to make it cute. It's not cute. Okay, our 6 trig functions. I put them in this order: sine, cosine, tangent, cotangent, secant, cosecant, because that's the order I like them in. So sine of theta is our opposite over a hypotenuse. We are also going to write it on here in terms of y and r and x, because you're also going to want those for your quiz. So opposite is y, hypotenuse is always r. So sine is opposite of a over hypotenuse. So cosine is ca. So that's adjacent over hypotenuse, which is x over r. And then tangent is OA, opposite of or adjacent. Which is y over x. Okay. Cosecant is the reciprocal of sine. So therefore it's hypotenuse over opposite, or r over y. The hospital's calling me. ELL? This is her. Welcome back to the video. My cholesterol's still high. My triglycerides did go down significantly in the last 6 months, though, in case you were wondering. Okay. I can break my own HIPAA, though. Yeah. All right, so cosecant. So we've got cosine. Reciprocal of cosine is secant. So just flip those guys over. So secant of theta would be hypotenuse over adjacent. And it would be r over x. What's up?
If your YouTube channel like got famous and started making money, still work here?
I don't think I could monetize me just like doing algebra with my 48 subscribers.
I know, but like once you get 5 million subscribers.
Yeah, what if you like blow up?
Yeah,
You
okay.
could be like the next Khan Academy guy. I don't even know what his name is, but like you could be like him.
I actually don't know what his name is. Is it Con?
I don't know.
Okay, and then reciprocal of tangent is cotangent. Cotangent of theta, instead of OA, it's O, so adjacent over opposite. X over Y. Okay, I realize this is like a gajillion and 17 things. That's why we're like literally putting it all down and like giving this to you to use, because it's a lot of pieces. And eventually it'll all click. Maybe. I don't know if it'll all click in the next 2.5 months before the school year's over. But eventually, like, everything like clicks together and makes sense, but it kind of all clicked at like once for me. All right, so let's talk about fundamental identities. I said you weren't going to need fundamental identities. You actually need this first one, and we're not going to write down the first one. So, do we all have that? Are we good?
Yeah. What's it called? Freaking heck.
Okay.
Oh yeah, do you think anyone that watches these videos believes that we're actually going to be a ghost?
Like
without seeing us, they just hear us in the back.
Yeah, this is a 5th grade classroom. Don't worry, guys. Okay. All right. So first fundamental identity is our reciprocal identities. And we are not going to write all those down. What those mean...
I already crossed that entire section out.
So did I. I'm going to erase it.
I don't care what you do.
Okay, good.
The first thing that you need to know, so like sine and cosecant are the opposites. So if I know sine, I can just flip it to get cosecant. If I know cosecant, I can flip it to get sine. That's true for each of our sets of reciprocals. We're not going to write that down. We could write like sine of theta is 1 over cosecant of theta, and cosecant of theta is 1 over sine of theta. We're not going to spend time writing that down. You then have a set of identities called the Pythagorean identities. They are sine squared of theta plus cosine squared of theta equals 1. And then there's several more versions of it that we're not going to write down because I don't want to.
So what's your favorite cuss word?
When I was a kid, we weren't allowed to say fart, so probably fart.
For real?
Yeah. My mom, would literally... We weren't allowed to say the F word, but we were allowed to say, every other cuss word. Well, my brother was, because similar to Brenda's family, my brother got away with anything. My brother was allowed to say, any cuss word, except for not fart.
That's weird.
Neither F word.
Why?
I don't know. My mom just didn't like it. Okay. Then we also have our quotient rules. And there's more versions of these, but the one I'm going to put down here is that tangent of theta is sine of theta over cosine of theta. You will not have to explicitly use just those on this review or test. I was looking for one thing to eliminate, and that's the thing I chose.
All of these data were
6-piece nugget for only $1.50.
That's 25 cents a nugget.
Wait, at Burger King?
That's a real world use of math.
Is that at Burger King?
No, $1.50. No, McDonald's. $1.50 for a 6-count.
Okay.
You can get $1.49 10-piece nugget at Burger King. I'm just saying.
BK, have it your way. You rule. This is gonna get copyright strike stricken because we're so good at singing.
We should do fast food restaurant theme song tier list.
Okay. Wait. Flip this over. Wait. Next thing I've got these two tables of all of our trig functions for 30, 45, 60, and then also I have our 0, 90, 180, 270. You're gonna need these for this quiz, but I'm putting them on there still. Okay, so sine of 30 degrees is 1/2. Sine of 45 degrees is square root of 2 over 2. Sine of 60 degrees is square root of 3 over 2. Fun fact, sine and cosine are co-functions. So sine of 30 is the same as cosine of 60. So it's 1/2.
So have you always lived in Topeka?
Sine of 45 is the same as cosine of 45. So it's square root of 2 over 2. And sine or cosine of 30 is the same as sine of 60. So it's square root of 3 over 2.
That's backwards.
What's backwards?
All of the numbers.
Yeah, that's because I went in the opposite order.
That's what I'm saying.
It's almost like they're co-functions.
They're co-functions. Yeah, what I literally just said.
What's a co-function?
Okay, tangent is just sine over cosine, but if you were to divide these out and then simplify radicals in your head, tangent of 30 degrees is square root of 3 over 3. Tangent of 45 degrees would be square root of 2 over 2 over square root of 2 over 2. Anything divided by itself is 1.
Oh, I'm slow. I just realized that the question I asked you a minute ago was dumb.
Square root of 3 over 2 over 1/2. You would flip this one. The 2's would cancel. It would be square root of 3. Do you need to know how I got that? No. Quite literally, that's fine right now. Okay. You will definitely need that table. I do not have anything on your quiz happening that involves your quadrantal angles. I was thinking of that word. 0, 90, 180, 270. So that's on the quadrants, so the next table. But I still want to go ahead and fill this out because we are going to talk about the unit circle next week, maybe week after, because next week's spring break. So sine, your values of sine are 0, 1, 0, -1.
Have you ever had a kid you hate so much you would have to give them an F?
No. Okay, well, first of all, your brother's in my seminar.
I know. He's okay.
Second of all, no, because guess what happens if I give a kid an F?
What?
Why is this cat an F?
No. I have to teach them Algebra 1 again.
True.
Yeah.
You could just like.
So it's in my best interest to like grimace my teeth and get you through. Okay. For cosine, your functions are 1, 0, -1, 0. And then tangent is still sine over cosine. So 0 divided by 1 is 0. 1 divided by 0 is undefined. 0 divided by -1 is 0. -1 divided by 0 is undefined.
Wait, how is 1 divided by 0 undefined?
Can't divide by 0. It sends you into a black hole.
Have you ever asked Siri what 0 divided by 0 is?
Yeah, have you? It used to say something about Cookie Monster, but I don't think it does anymore. Hey Siri, what's 0 divided by 0? You gonna talk?
My Siri doesn't.
Okay, it didn't even say the funny Cookie
I
Monster
want to
thing.
do it. What is 0 divided by 0? Just said my answer is no.
Okay. So we've got 3 more things to talk about. Next one we want to talk about is our signs of our trig function. That's the one that we use All-Star Trig class for as our mnemonic. So all of our trig functions are positive in quadrant 1. Sine, and therefore its reciprocal cosecant, are positive in quadrant 2. Trig is tangent, and therefore its reciprocal cotangent are positive in quadrant 3. And cosine, and therefore its reciprocal secant, are positive in quadrant 4.
Finding reference angles.
Okay. Next thing we have on here is finding reference angles. Reference angles is what we were doing the most recently. That's when we have an angle somewhere between 0 and 360 degrees, but we want to make it between 0 and 90, 0 and 90, 0 and 90, or 0 and 90, because it makes our life easier, and then we can just use whether it's positive or negative from what we just did. So for our reference angles, for quadrant 1, we do not need to find any reference angles. Because if you're in quadrant 1, you're already in between 0 and 90. If you are in quadrant 2, when you find your reference angle, you're trying to find the angle from here up, that little guy right there. Our reference angle will always be theta prime. So to find this, you're either going to do theta prime equals 180 minus theta, if you're in degrees, or if you're in radians, it would be theta prime equals pi minus theta.
Sounds like a bunch of rats.
Okay, if you are in quadrant 3 and you are trying to find your reference angle, your goal is to find this angle right here. So for that one, you'll take your angle minus the 180. So theta prime equals your theta minus 180 degrees, or theta prime equals theta minus pi. Okay, last one, quadrant 4 over here. If you have an angle in quadrant 4 that you're trying to find a reference angle for, you would be trying to find this angle in between the positive x-axis down to that point. So for quadrant 4, I would do 360 minus my entire angle to give me what I have left there. So theta prime equals 360 degrees minus theta, or 360 degrees is the same as 2 pi. So it'd be theta prime equals 2 pi. I said it, but then I converted it back. 2 pi minus theta. Okay. Remember when I was saying that we haven't made it very far? We've done a lot of things. It's just really compressed into these like 3 sections of the textbook.
Yeah, exactly. You've done so much work in here when you do like exactly.
Okay. One last thing that I want to talk about is angles in standard position, which is super similar to our reference angles here. I want to label the X, the Y, and the R though, because I have a feeling that will help you when you go to actually like evaluate the trig functions. Having X, Y, and R for all 4 quadrants will help you. So in quadrant 1, an angle that is in standard position would be here-ish. For this angle, my R value is my radius. My X value is on my x-axis. My Y value is my distance from the x-axis. For any angle in quadrant 2, my Y value would be here. My X value would be here. This would still be my R. I'm trying different funny shaped triangles for each of these. Okay. Quadrant 3. My R value is still from the center out to my point. My X value is still on my x-axis. My Y value is still on my Y. Same thing. X is on my x-axis. Y is on my Y. My R value is still my radius. For any point X comma Y, if you want to find that distance R, R is the square root of X squared plus Y squared. That's just the Pythagorean theorem. Okay. Right now, keep this piece of paper for the rest of the semester, first of all. Second of all, I'm going to give you guys a review. Your review is longer than your test. Your review is 2 pages front and back. Your test is 1 page front and back. Quiz, whatever we want to call it. I'm going to let you use this sheet on your quiz. I'm going to let you use your review on your quiz. Okay? So, if you can do a problem on the review, the problems are going to be super similar on the quiz. I'm not trying to trip you up and not trying to make your lives awful. I'm just trying to get you to do a little bit of trigonometry.